Hello to all of you students. Welcome to my YouTube channel. So, actually, we'll be starting physics, the first chapter, which is in class 12th. So, we will be starting from electric charges and field, and we will try to create separate videos which would be compiled together, and there would be subparts of every chapter, like in different videos. Okay, so when a particular suppose chapter is completed, then we will create separate playlist chapter wise, so that systematically each and every student can just go in and have an entire overview of the chapter. Okay, so today we will be talking about some basic properties of electric charge. Like there are other topics as well, like how what are the nature of charges, then you can say what are conductors and insulators, right? And then charging by induction. So apart from those topics, today we will be starting from basic properties of electric charge. Later on we will also cover those topics as well. So let's just look at three basic properties which are there for electric charges. First is additivity of charges. Okay, that means how do you add charges? So it's just similar to the process that we add numbers, right? Like plus 5 minus 3 is equal to plus 2, plus 7 minus 5 is also plus 2. So the basic thing is that when you are adding charges, so you have to keep in mind that they will be added along with their signs. Okay, that means you have to take into consideration their sign as well. Like plus 8 coulomb minus plus 6 coulomb minus 8 coulomb, this will be minus 2, right? Then minus 2 plus 11 again will be plus 9, and finally plus 9 and suppose minus 20, it will give you minus 11 coulomb. So we have seen that actually we have added charges keeping in mind their sign, just simple manner in which we add numbers. Now next basic property of electric charge is that charge is conserved. Now what do you mean by charge is conserved? Suppose that you are taking an isolated system, right? And in this isolated system there are four different bodies, and let's just assume that they are having certain amount of charge. That means they are charged. Okay, like suppose that the charge on this body is minus 5 coulomb, the charge on this body is plus suppose 4 coulomb. Okay, and the charge on this body is suppose plus 11 coulomb, and the charge on this body is suppose minus 10 coulomb. Now we have just assigned arbitrary value of charges. This was a different case in which we just added. Now let's just suppose that somehow these two bodies came in contact and there was certain amount of transfer of charge. Like this was having minus 5 coulomb, so this body just transferred minus 2 coulomb of charge on this body. Okay, now what will happen? If this body is transferring a charge of minus 2 coulomb, that means this body will gain a charge of minus 2 coulomb. So the net charge on this body, the new charge, will be minus 2 plus 4. Again the same rule, we have to just apply the additivity of charges to find the resultant charge on both the separate bodies. Okay, so minus 2 plus 4 will give you plus 2 coulomb. That means this will be the charge remaining on this body after it has gained minus 2 coulomb of charge. Now this has lost minus 2 coulomb of charge. So for this the net charge will be minus 5 minus of minus 2, that will become plus 2. So this will have a final charge of minus 3 coulomb. Now if you look at this minus 3 and plus 2, if you just add both of them, the resultant will be minus 1 coulomb only. Okay. Now even if you add the original charges, that is minus 5 and plus 4, what would you get? You would get again the resultant as minus 1 coulomb. So this was the point that we were talking about, that actually if the system is isolated, even if there are more than one bodies in that isolated system and the charge is getting transferred from one body to another body, then also overall in the entire system the charge will remain the same. Like what is the initial charge? Minus 5 plus 4 minus 1 coulomb, minus 1 plus 11 plus 10 plus 10 minus 10, 0 coulomb. Later on also minus 3 plus 2 minus 1, minus 1 plus 11 plus 10, and plus 10 minus 10 0 coulomb. That means in an isolator system, whatever happens inside the system, it would produce no change in the total charge of the system. It would remain conserved. Now let's just also talk about quantization of charge. What do we understand by quantization of charge? So quantization of charge actually tells you that charge is considered in a certain multiple of a certain value. And what is that value? That value is one electronic charge, that is equal to 1.6 into 10 to the power of minus 19 coulomb. Now what is the importance of this electronic charge? See, we know that when suppose two bodies are being rubbed, or whenever there is a transfer of charge, so basically it is the electrons only, isn't it? It is the electrons only which are transferred from one body to another body. That means the charge will always be transferred in multiples of electrons, isn't it? Suppose n times electrons is getting transferred. So how much amount of charge is getting transferred? That is n into 1.6 into 10 to the power of minus 19 coulomb, isn't it? So that means the charge gained or lost by a body, of course in terms of electronic charge, which is negative in nature, we know that on an electron the charge is negative. So the entire amount of charge getting transferred will always be in multiples of this, isn't it? Now this is one thing. Now let's just also talk about two different cases. One is when we are talking about the macro scale. Now macro scale means what? When we are actually talking about a very large amount of charge. Suppose if we talk about one like millicoulomb, or you can say 1 coulomb. Now if you want to understand that how many electronic charges will make up 1 coulomb, so we know that in 1 electron unit of charge, what is the amount of charge? 1.6 into 10 to the power minus 19. So that means if you divide 1 by 1.6 into 10 to the power of minus 19, that will give you the total number of electrons that would be required to get 1 coulomb of charge. Now if you do this, so this is same as 10 into 10 to the power of 18 divided by 1.6. Now this is roughly 1.6 into 6, that is 9.6. Then 4 will be there, so you do 2, 3.2, then 80 will be there, 8 basically will be there, so it will be 5. So approximately 6.25 into 10 to the power of 18 electrons, actually when they combine they create a charge of 1 coulomb. Now this is very large amount of electrons, isn't it? You can see that this is a very large quantity of electrons. So suppose if you want to add 10 electron unit of charge in this so huge amount of electrons, or if you subtract suppose 25 electron charges, will it make any difference? No, because already something which is so much of large, if you add 10 or subtract minus 25, it would be same as if we say that it is equal to the same quantity of charge, because we can eliminate it because it is so small as compared to the original value. But if we are talking about micro scale, isn't it? Suppose that we are talking on the micro level, then what will happen? So suppose there is a system in which there is plus 10 coulombs of charge, or maybe no, since we are talking about micro, so we will not consider coulomb, sorry. So suppose there is plus 10 electron charge present anywhere. Now if we suppose add minus 4 electron unit of charge, or suppose, then what will happen? Since this was electronic charge, so suppose we will be adding plus 4 electron. So sorry, if we are adding plus 4 electron unit of charge, now can we neglect this? No. Why? Because earlier it was 10 electrons, so now we have added 4 more electron units of charges, so the total electron unit of charges is 14 electrons. Now what is the change? That means 4 electron units of charges is getting increased. So what is the change in terms of percentage? You can see that it is a change of 40%, which is significant. We cannot now exclude this factor. So when we are talking about the micro scale, the point of focus was that when we are talking about micro units of charges, That means in a multiples of a few electrons, maybe a few hundred as well. Even suppose if there's a few hundred of electron unit charges, you add 10 or 20, that is also significant, isn't it? Or if you add 50 units of electronic charges, so in this case you won't eliminate this. So in micro scale, even one electron unit of charge is significant, isn't it? Because it can produce a significant amount of change in the final value, isn't it? But if we are talking about a macro scale, then there is not much significant change, isn't it? So I hope you liked the video. Okay, thank you.